Hi, this is Mr. Lemansky, and this is Algebra 1, Frankenmuth High School. And the videos that you'll be watching this year are my lessons that I will do for you. You'll watch these lessons at home in advance of coming into class the next day. And the reason I'd like to do it that way is instead of me spending 25 minutes hashing through a lesson with you during class time, I think it's going to be a more effective way for you to learn if you watch the video the night before, which will go over what we're going to cover in class the next day. You then come to class, and with that background knowledge already there, you then show up to class, and now there's a couple things that could happen. If you didn't understand what I put in my video, you could be asking questions about that, and I could be answering those specific questions that you have. If you have specific questions about certain problems that you're not sure about how to do, we can actually attack that and go over the things you really don't understand. And then the third benefit of having the video or the lesson explanation watched the night before is if you have no questions, you could come to class and just get started on the homework and not have any homework to take home. Okay, so I guess those would be the main reasons I need you to watch these videos, okay? Now, when you watch the videos, I think it's a good idea to have a notebook and to take notes. And I think that's part of being a teacher and teaching freshmen. It's not just trying to teach you the algebra, it's trying to teach you how to be successful as a student overall. And so I want to talk about a couple things here regarding what's a good way to take notes, all right? So when you're watching this video today, I'd hope that you'd have a notebook there and you're going to take some notes over what we're going to cover. I would recommend using a spiral notebook for the video and any class notes you might take. Only use this notebook for algebra notes, okay? I've seen kids, they come to school, they have a notebook and they have everything in there, every class possible. They're writing letters to their boyfriends and girlfriends in there. They're putting a whole bunch of stuff in there. And by the time you get halfway through the year, they have papers from all over the place. It's just basically a bird's nest of papers. They can't keep anything in order, and now it's not helping them understand the material. So the first thing I'd recommend is get a spiral notebook that you're only going to use for this class, and you're only going to use that notebook for notes in this class. It doesn't have to be a 500-page notebook. I think one of those thinner, college-ruled, 100-page notebooks that you can just use for class notes will help keep yourself organized going forward. That way, when you have to study for a final exam in January or at the end of the year in June, you have all those notes, all those things in one place, and you're not going from one book to another, from this paper to that paper. It's all in order for you. Okay, that will make your studying easier. The second thing here, I will check to see that you watch the videos before class with unannounced quizzes or audits of your notes. I will let you use your notes that you took from the night before on these quizzes and audits. So you reward yourself by taking decent notes and coming to class the next day having watched that video. If you don't watch the video, I'm not going to jump and yell and scream at you, but if I give you an unannounced quiz and you haven't watched the video and you take a 0 on it, then I'm not going to have any sympathy on you for that either. Okay, so definitely want to watch the video. Keep the class notes in your notebook as you are watching the video, or keep the video notes, I guess would be the best way to say that. And then the third thing, to take good notes, when you're watching these videos, write down key ideas or examples, okay? And that's what we're trying to keep in our notebook. I don't know that you have to necessarily write every single thing I put on these videos, but the notes you have should help keep in your mind or help refresh in your mind the main ideas of what the lesson's about. Now, this first lesson, when you go to Chapter 1, and if you want to take a peek, if you go to page 1 in your text, you'll notice this first chapter is called Expressions, Equations, and Functions. And this first chapter, I'd say for sure, the first 5 sections of it are a definite review of things that you would have learned in 7th and 8th grade, basic operations overall of arithmetic. And the first section of this chapter, if you go to page 2, is called Evaluating Expressions. So let's talk about what that means. All right. I guess one more thing I should have said before I do that. As you take notes for this lesson, it might not be a bad idea for you to write today's date. I just put this as an example. I know it's not the 7th, but let's say 9/7, and it'd be 2012 for you. And then this is lesson 1-1. So now any notes you take after that, when you come back 3 weeks later or whatever, and you want to study for a chapter test, you'll be able to see, hey, on this date I took lesson 1-1 notes, and here they are. All right. Again, just keep your algebra notes in this notebook. Don't put a bunch of other stuff in there, because as the year goes on, as you do that, it becomes a cluttered mess. It becomes disorganized, and then the notebook really doesn't help you. All right. Okay, so lesson 1-1. If you're on page 2, there's a few things few vocabulary we want to review. Okay. The first vocabulary word, and I'm pretty sure you know this, is variable. And you probably are aware of variable is a letter or a symbol that represents one or more numbers. Okay. I'm not going to spend a lot more time on that. I'm pretty sure that you are aware of what a variable is. Now, an expression, sometimes I know I see students that when I ask what's an expression, and they've heard of the word, but they're not really clear what it means. An expression is when you have numbers, variables, operations. I better write in operations. When I say that, I mean adding, subtracting, multiplying, or dividing. When you have numbers or variables with operations, that's called an expression. Like here would be a simple expression like 3 plus 2 would be an expression. It's a combination of numbers and operations. Or something like 5xy, 5 times x times y. That would be an expression. All right? So when you have it, well, let me just give you one more example. 15. The number 15 is an expression. It's numbers. As long as you have numbers, variables, or operations, that is considered an expression. Now, an algebraic expression has a specific meaning. I think you probably understand or have a good idea what an expression is. An algebraic expression, and this is kind of, I better change something here. I just noticed I spelled algebraic wrong. That's better. Okay, an algebraic expression is an expression that has a variable in it. So an expression could be numbers, it could be variables with operations. To be an algebraic expression, it must have variables in it. And if you look at the top of page 2, you'll see a chart, and it has some expressions, and specifically algebraic expressions they made. I made up a few examples of algebraic expressions here, like 3n plus 2. Or 17x, or just m, okay? Any of those would be examples of algebraic expressions. So I perceive that probably makes sense to you. If not, when you come to class tomorrow, we can talk more about that. Raise your hand right away, and we can talk more about what expressions are, okay? Because that's the first thing we have to be able to understand is what's an expression. Now, you'll notice after that, the next thing, I should have erased these to start. The next thing is, if you look on the bottom part of page 2, they're going to talk about evaluating an algebraic expression. So the question is, when they ask us to evaluate, what is that asking us to do? Well, evaluate basically means they want us to take whatever the values of the variables are, replace those in, and get the answer. Most of my students say, are you asking me to get the answer? Well, that's what evaluating is. It basically means get the answer. So an example of that might be like if you look at number 4 in the homework. I'll do this with you when I'm going through examples. I'll normally go to your homework, and we'll just work ahead a little bit, and we'll do a few problems together. If you look at number 4, the directions say evaluate the expression. That basically means get the answer, and in number 4 you see 0.4 times r. Remember, when there's no symbol between a number and a variable, that means multiply. They want us to evaluate 0.4 times r when r is 6. Well, what that means is to take 6, replace r with 6 because r is 6, and then take 0.4 times 6, and that's 2.4. One thing I'm really big about at this level, you're in 9th grade now, I need to know that you can do some basic things without your calculator, and in fact, I can't always test you with your calculator because certain things I'm going to ask you to do, if you use your calculator, it really doesn't mean you understand it. Like, for example, the next section we're going to cover starting tomorrow would be order of operations. If I just let you use your calculator, you could type everything in your calculator, and it really doesn't tell me that you understand anything other than plugging stuff in your calculator. So in many cases in the first chapter, a lot of your quizzes and tests, I will tell you, will be non-calculator. So as much as possible, as you're doing this in the book, I would not be using your calculator. I would be trying to do these without, okay? And this is one you definitely can. 0.4 times 6, well, 4 times 6 is 24. 0.4 times 6, since there's one decimal place, it's 24 with one decimal place, 2.4. Okay, that would be an example of evaluating expression. Here's a second example in problem 6. You'll notice it's 1.6 minus g, and they say g is 1.2. So if we replace g with 1.2, we'd have 1.6 minus 1.2, and that's 0.4. Okay, so there would be two examples of us evaluating an expression. And again, evaluating expression is basically just asking us to get the answer. All right. Some other things they're going to ask of us, and I wish I would have turned these layers off. I'll do them like this so I can go in order. They will ask us, and this is more concentrated on page 3, they're going to have us evaluate expressions that have exponents. And if you look in the middle of page 3, you'll see a green heading, expressions using exponents. There's 3 vocabulary words, and normally when you read in the book, you'll see the vocabulary highlighted. We see power, base, and exponent. Sometimes those words are a little misconstrued. This number raised is the exponent. I think most of us understand that. The base, some of us might not remember this number is called the base. A lot of us think this 2 is the power, because sometimes we say 4 to the second power, which is the proper way to say it. But actually, this entire thing represents the power. All right, so when we say 4 to the second power, the 2 really isn't the power. The entire statement, 4 to the second, represents the power. The 2 is called the exponent, the 4 is called the base, and 4 to the second power obviously means 16. Now, a common mistake I see people make, and I think I might have put this in my next slide. Here's a common mistake that people make. We got to be aware here, okay? When you have, for example, 2 to the third power, the most common mistake, and I wrote this out in red, whenever I try to write in red on these videos, it's showing you that something's wrong, okay? So here would be a common wrong that people would make. They look at 2 to the third power, and they think 2 times 3. And then they write, well, that's 6. Well, that's wrong, because 2 to the third power does not mean 2 times 3. It means I want 3 factors of 2. Now, 3 factors of 2 means that I want to take 3 factors of 2. You can see that here, 1 factor, 2 factor, 3 factor. I have 3 factors of 2 multiplied together. That's what 2 to the third power means. 2 to the third power is actually 8. Okay, so 2 to the third power is actually 8. And so that's something to be aware of. I'm not sure why I put that in. I'm just going to erase that. That's not important. Okay, so when you look at today's homework, and again, some of these exponents, some of these bases to exponents, I would not expect you to do without a calculator. Like I'm looking on page number 5 right now. Honestly, I'm a math teacher. I'm looking at number 29. 11 to the third power, I guess I could take out pen and paper, but off the top of my head, I'm not really sure what it is, okay? But stuff like 10 to the second power, I would expect you, without a calculator, to know that 10 squared means 10 times 10, and 10 times 10 is 100. I would expect you, in a question like number 30, when it's 5 to the third power, to be able to say, hey, 5 times 5 is 25, and then 25 times that third factor of 5 is 125. I would expect you to be able to do those without a calculator, okay? So it's important, again, that we try to do these without. Some of these problems you'll see a fraction to a power, all right? And this always drives me nuts. I always have people, when they see a fraction to a power, they want to right away change the problem into a decimal because they are so used to using their calculator, they don't have a clue of how to take a fraction to a power. Don't change it into a decimal. I have an example here. Consider 2/5 to the second power. We don't need to change this to 0.4. In fact, if you do, I don't think you're making it easier. You're making it harder. When you have 2/5 to the second power, you just take that second power and apply it to the numerator and the denominator. Just take that second power, and you want to take 2 to the second power and 5 to the second power. Well, 2 to the second power is 2 times 2, that's 4. And 5 to the second power is 5 times 5 is 25. That's it. 2/5 to the second power is 4/25. So I'll know right away if some of you didn't watch the video when I give you a quiz and I don't let you use a calculator, and inevitably I always have a few people that try writing these as decimals and then applying the exponent. Well, those answers don't always work out very nice. You're much better off without a calculator keeping it in fractional form and applying that exponent to the numerator. Remember, numerator is the top of the fraction, and the denominator, which is the bottom of the fraction. Let's see what I have on my next slide. I'm just looking at some more homework questions here. If you look at problems 16 to 23, they don't actually ask you to calculate anything in 16 to 23. All they want you to do, the directions say, write the power, 2 words, and as a product. So let's write it out in words. So in 16, when I read that, it's 12 to the 5th power. Well, here I wrote it out in words. That's the first thing I was asked to do. Then they want me writing this as a product. Now, a product, remember, the word product is a fancy way of saying write it out as a multiplication. Product is multiplication. So 12 to the 5th power means I want 5 factors of 12 multiplied together. So there, for number 16, I wrote this as a power in words, and I wrote it as a product right here. Let's see here. Got a couple more I did. Get that out of the way. If you jump ahead to 26, now again, now when they say evaluate the power, that basically means get the answer. Let me erase that. So in 26, you'll notice 3 to the 2nd power. 3 to the 2nd power means 3 times 3, 2 factors of 3, that's 9. In 36, this is another one. I would definitely expect that you could do this without a calculator. Okay, 2/3 to the 4th power. First of all, don't change this into a decimal, because if you're not using a calculator and you try changing this into 0.6 repeating and then doing that to the 4th power, you're going to be miserable doing that. In fact, I'd hate math too if that's how I had to do it. You keep this as a fraction. You just apply the 4th power to each. Okay, 2 to the 4th power is definitely something we can do in our head. Okay, it's 4 factors of 2 multiplied together. So think, what is 2 times 2? And you probably came up with 4. So now this is 4. Now you take 4 times the extra 2 here, and that's 8. So these give you 8. And then 8 times 2, well, that's 16. So my numerator would be 16. Maybe I should show that and cover it up. So my numerator is definitely 16. Now all I got to do is get my denominator. Well, 3 times 3 here is 9. Maybe I should underline this. So this is 9. 3 times 3 is 9. Well, isn't 3 times 3 over here 9? Remember, when you're multiplying, you can do it in any order you want. So really, I have 9 here times 9 here. Well, 9 and 9 is 81. 1681st is 2 to the 2/3 of the 4th power when I evaluate it. It's 1681st. Okay, and I'm getting close to being done with this video. One other thing they will ask us to do besides evaluating expressions, at the end they have a couple questions regarding area and volume. Just want to review that a little bit. And they're going to have us working with areas and volumes of cubes or squares. Okay, so areas of squares, volumes of cubes. Area is always 2-dimensional. You know, when you think about area, it's square feet, square inches. You can measure area in square miles, square meters. Volume is always how much can you fill something with. Volume is always 3-dimensional, like cubic feet or cubic inches or cubic miles or cubic meters. Okay, things of that nature. So when you have a square and you want to find the area of a square, the formula for that's very easy. You just take the side length and you square it, because to find the area of a square is a type of rectangle. Length times width gives you area. Well, since these are both the same, side times side, side squared gives me the area. Okay? So, and one other thing I wanted to remind people of with this, because people get confused here, area, side by side is area, but perimeter is finding the distance all the way around. So perimeter and area are not the same thing. Area is the amount of space inside the figure. Perimeter is the distance around. The distance around this figure would be S plus S plus S plus S. The perimeter of this would actually be 4S. Okay? And then when we go to volume, okay, when you have volume of a cube, let me kind of draw a picture of a cube real quick as best I can. Here's a cube. And a cube, remember, all sides are the same length. So I'm not a great artist, but I'm trying as best I can to draw something that looks like that, okay? So if all these are the same length, the volume of this would be the length times the width times the height. Well, since the length, width, and height are all the same, it'd be S times S times S. It'd be 3 factors of S multiplied together. So the volume of a cube is just side length cubed. Okay? And I'm just going to quickly go over one last problem so I can stop this video then and be done with it for today. I don't want to make the videos 4 hours long or anything. So if you look at a question like 54, I did, or at least started a problem with you. It says evaluate the volume, evaluate for part A, find the volume of each bin. Well, bin A, since it has a side length of 6 inches, all you'd have to do is take the volume formula, volume equals side length cubed. You replace S with 6, and 6 to the third power is 216 cubic inches. Bin B, since the side length is 12, 12 cubed is 1,728 cubic inches, and at least I got you started on that. So, and then you'll have to figure out bin C, and then they ask you a couple questions in part B and C to compare. So that should at least get you going on what tomorrow's book work is over. If you have no questions, I'm going to ask if you have questions to start class. If you do, we can go over anything that you had questions on regarding this video. If you don't have questions, you could actually get this started on the work right now if you wanted to, or you could wait till class time tomorrow. All right? I will see you tomorrow.